1. So question number 1 states that it is known that x plus y is equal to 7 and xy is equal to 12. Find the value of x squared plus y squared. So how do we solve this kind of question? Okay, so for this question, we'll try to start with this question right now. I just wanted to clarify, are you ready, everyone? Again, for those who are just now who entered, please again, try to put your full name in the chat box. And again, please do answer first. Are you ready, everyone? Are you there? Okay, again, good afternoon. Good afternoon, everyone. Okay, right, okay. Okay, that's good. That's good. So assuming that those who have sent their chat are here, and then let's try to start with this first question. So what is the value of x squared plus y squared? So this one's a little bit of an easy one, okay, because we know that we can basically solve this question by what we call this one? By making or squaring x plus y equals to 7. So you just square x plus y is equal to 7, both sides. So you square that, square this, and therefore that will become equivalent to x squared plus 2xy plus y squared is equal to 49. I'm so sorry for my handwriting, by the way. So that will become the case for that now. So x squared plus y squared is equivalent to 2xy plus y squared is equal to 49. Then we can transpose the 2xy to the other side, and what we'll have is like we'll have x squared plus y squared right now is equal to 49 minus 2xy, but we know xy is 12. So basically that's 49 minus 24. And then the answer is equal to 25 for this question. So the first question, the answer is 25. Yes, correct. It's 25. Question clarification for that before we move forward to our next problem. Okay, after the question, I'm usually giving you a chance to ask a question. I'll give you 30 seconds to 1 minute to clarify or ask a question based on the solution that we have. So again, the correct answer for the first one, this is just a suggested solution from me, and then the correct answer or the answer for that is that. Again, question clarification for that, everyone. Okay, if you don't have any question, yes, you can say none so that I can proceed. But again, I'm usually giving you 30 seconds to 1 minute to ask question. I'm so sorry for my handwriting, by the way. That is how my handwriting work. Okay, sige. Okay, I can see that there's none. Okay, if there's none, let's try to move forward with the next question. Yeah. None, none, none. Okay, that's good. Okay, let's try to move forward to the next question. Okay, how about question number 2? Okay, let's try to proceed with question number 2. So question number 2 states that, okay, here it states the following situation, right? Okay, so for question number 2, the given is this one. Find the number of factors of 2,520. Find the number of factors of 2,000. This is a usual question. So how do we attack this question, right? So for this question, again, we need to take note that 2,520. We need to do the prime factorization as much as possible of 2,520. So for those who know the prime factorization of 2,520, that's quite good, right? But for those who don't know, then I wanted you to, as much as possible, try to study further for that. So when you say 2,520, we can break that one into like 2 times, okay, a little bit long. That's actually 2,520, but yeah, I'll be giving you like that one, the challenge for that one. Try to find the prime factors for that 2,520. So the prime factor of 2,520 is actually 2 cubed. Okay, it's 2 cubed, right? Not there, not there. Okay. We know, or I mean, that's the challenge for it. I think you're grade 8 already, or secondary 2. I think you know how to do your prime factorization already. So that's 2 cubed times, okay, wait. Okay. Okay, you'll be having like 2 cubed. Wait lang. Okay, we'll be having like 2 cubed is equivalent to, or that's 2,520 is actually equivalent to 2 cubed times 3 uh 3 squared times 5 times 7. So as you can see, that's times 5 times 7. Okay, I'll be putting multiplication sign. Again, I'm sorry for my handwriting. Times 7. So find the number of factors. Okay, number of factors. To solve for that, what will be happening is that we're going to just, how will we do that one? We're just going to add each exponents by 1. Like 3 plus 1 times 2 plus 1 times 1 plus 1 for the exponent of 5, which is 1 here. Exponent 7 is also 1. Then 1 plus 1 for the case of 7 also. Okay, after you do that one, we multiply each of those numbers. So 1 plus 1 for that matter. And then after that one, you can now find out the number of factors. So 1 plus 1 here. So that's equal to 4 times 3 times 2 times 2. So that's 12. That's 24, 48. Therefore, the correct answer for question number 2 is 48. Question clarification for that before we move forward to our next problem. Again, question clarification for that one before we move forward to our next problem, everyone. That's question number 2. If there's none, you can just say none also in the chat box. That's good. Okay, right. Right. Okay, if that's the case, you try to move forward. You said none, 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 none. Okay, that's good. Okay, let's try to move forward to question number 3. Find the value of the sum of 1 plus 2 plus 3 plus 4 until 2015. Okay, this is summation of consecutive numbers. So how do we solve for this question, right? How do we solve for this question? So for this one here, we need to be familiar with the 1 plus 2 plus 3 or the summation of consecutive numbers. Okay, and then it's 1 to n. So if the summation from 1 to n, 1 plus 2 plus 3 plus that until n is actually equivalent to n times n plus 1 over 2. It's very important for those who know. But you can actually apply also the sequences, right? You can do also sequences. So for this guy, this is like the summation from 1 to n, for this will become just equal to 2015 because your n is 2015. Oh, sorry for my handwriting again. Times times your n plus 1, 2015 plus 1, that's 2016, divided by 2. Okay, so if you do that one, we can cancel out 2016, right? Okay, we can cancel out 2016 here, cancel this one out, it's like 1008. So we can just basically multiply 2015 times 1008. So what is the product of 2015 times 1008? That's a challenge. That's a challenge, multiplying a very big number. So that's 2015 times 1008. That's equivalent to 2015 times 1008. That's equivalent to 2000 or 203. 203. Okay, 203. 1120. 203 or that's basically 2,031,120. And that is the answer to our question. Question and clarification for that before we move forward to our next number. Okay, that's the answer for that question. Again, question, clarification so far, everyone. Tell me if I'm too fast. Okay, also, okay, I'll give you 30 seconds, 1 minute to ask if there are any questions with this. None, none. Okay. Right. 30 seconds, 1 minute. Okay. I can see that there's none. Okay, if there's none, yes, none. Okay, let's try to move forward to our next problem. Question number, what do we call this one? Question number of 4. Okay. find the remainder when 1023 or 1234 is divided by 6. So how do we solve for this one? So basically, we can apply some modulo pattern for this. So we know that we're trying to find first 1200. Okay, or let's try to see what will be the what we call this. What is 1234 is congruent to what? What's the remainder being divided by 6? That's actually remainder 4. So 4 mod 6, like that. Then, if you'll try to see the pattern also, meaning we can actually exponent this one, or 6 is the exponent. We can do tophian function, but 1234 is actually not rational number. So what can we do is we just try to find the pattern. So that's like it's like congruent to 4 mod 6. So therefore we can say that 1304 is congruent to 4 squared, which is congruent to 16. Okay, which is equal to 16, which is congruent to what? 16 when divided by 6, that's actually 4 mod 6. So as you can see, the remainder is always 4. Even though you square that 1, it's always 4. Okay, so therefore, all throughout, the remainder for this, if you divide 1234 in any exponent, the remainder is also 4 for that. So therefore, because of that situation, we can say that 1, 2, 3, 4 raised to 1001 to any exponent is still congruent to 4 mod 6. And therefore, the remainder for this question is always equal to 4. Are we clear with that one, everyone? Question and clarification for that. But you need to check the pattern in terms of the power of 1234. And after you see the pattern, you will see that that is the only way that we can have that. Okay, that's the only way that we can have that one. Okay, clear? Question, clarification? Okay, right. Okay, if there's no question, let's try to move forward with the next one. Okay, let's try to move forward to the next question. Right. Oh, wait, no. The 30 seconds to 1 minute is not yet done. And if you have any question, you have 30 seconds to 1 minute to ask a question for that one. Okay. Uh-huh. None. Okay. I can see that there's none. Okay, let's try to move forward. Again, tell me if I'm too fast, everyone. Try to move forward to question number 5. If square root of 60 plus 18 square root of 11 is equal to square root of A plus square root of B, what will be the value of AB? Okay, so this one is a little bit of a dynastic. Okay, the best way again for this one is actually we can square this one both sides like that. So if you square that one, what will happen is you have 60 plus 18 square root of 11 is equal to, yeah, I think it should be understood like that one. Okay, let me erase that one. So we'll be going to squaring, or we're going to square this one both sides. Square this one. Okay, once you square that one, what will happen is that the square root will cancel it out. So that will become 60 plus 18 square root of 11, like that. And if you square root of A plus square root of B, what will happen for that one is actually we're going to have square root of 11, right? It'll become A square of A square root of A squared plus 2 square root of AB plus B. Okay, and then we can rearrange it in such a way that you'll be having the following scenario. What will happen is you have 60 plus 18 square root of 11 is equal to right now A plus B times 2 square root of AB, like that, or plus 2 square root of AB. So because of that, what can we conclude out of that? What can we conclude is that your radical part is equal to the radical part on the other side, because and the whole number part is equal to the whole number part on the other side. Okay, so basically what will happen is this. So as you can see, we can actually equate this two. So we know that 60 is equal to, we know that 60 right now is equal to what? 60 is equivalent to the sum of A plus B, and then 2 square root of AB is equal to 18 square root of 11. So what can we say is that we're trying to have to double check. So we square both sides, or we divide both sides by 2, they'll become square root of AB is equal to 9 square root of 11, like that. 9 square root of 11 is 9, not A. Then after that one, we can just like square again both sides if you like, right? We can square both sides if you like, so that we can have, if we square this one both sides again, what will happen is that you'll be having square this like that. So AB right now, the product, the one that you have is 81 times 11, which is actually equivalent to 1,891. But you need to double check. Are there two numbers? Yeah, but yeah, we're trying to solve only for AB. So AB is actually 891 for this question. Okay, we'll try to find two numbers that adds up. 11, yeah, 81, 811. 891 is the product of AB. Wait, did you see the solution for that one, everyone? By the way, I forgot to that I paused the meeting. Okay, question clarification for that one. Okay. Did you see the solution, everyone? I'm so sorry if ever I paused the screen and you did not see the solution for that. Okay. Okay. If there's none, okay, let's try to move forward to the next number or next question. Okay, let's try to move forward to the next question. Question number 6, right? We'll try to go with question number 6. Yes. Yeah. It did not say that your A and B are actually did not say that your A and B are actually integers, right? So A plus B is equal to 60. Even though that A plus B is equal to 60 for that one, and then how come that AB is equal to 891? Okay, so there might be some values that will give us that one. Okay, there's technically their value is not what we call this one. It's not exact in terms of nature. Let's say it's not exactly whole number. I think you're thinking that A and B are integers here, but so far it didn't say that's an integer. So we can actually have different values there, and eventually will give us 891 as the product for that. It could be a possible one. Here for this one, this is the concept of radical. So if you have a radical part and a whole number part, A and B, there are a radical part and a whole number part for this one. So there, by analysis, you can say that this one is the one with radical, this one is one without radical. So we can say that your 18 square root of 11 is only equivalent to the radical part of the other side, and vice versa. Yeah, and that's the solution for that one, or that's the main thing for that one, actually. Are we clear with that, everyone? Because radical part should be equal to the radical part, and the non-radical part should be equal to the non-radical part. Okay, that's actually the analysis for that one. Okay, right. But yeah, it's actually not that confusing if ever this A and B are actually having equivalent to a number that has, oh, pwede kasi no 81. Wait. We'll try to see. Let's try to see. There is a actually whole number. I think it's a whole number. Wait. Because this one like what? We can break it to 3 and 27. Yeah, there you go. If you break that one, you're 81. 81 is 3 and 27. You can prove actually that the two numbers are 33 and 27. And there you go. Okay, sorry, I forgot. Yeah, because actually the power of this one is the one way is the nesting for this. I think ito, para mas makonclude natin yan na the whole number part is equal to the, it should be stated that A and B are integers. And as you can see, it's become an integer. As you can see, that 33 and 27 is 891, and 33 plus 27 is 60. Okay, those are the two numbers actually. So try to research more about the nesting. It's actually the process we call the nesting. That's quite related to this one. And yeah, that's how we solve that question. As you can see, a little bit of a guess and check. 33 and 27 will satisfy our value. That's the value of A and B, actually. That's why 891. We can actually get that one, but as you can see, AB is the only thing that we need to get. And then once we get that AB part, we can say, we can just double check that. Is there really a number that adds up to 60 and their product is 891? So as you can see, there are two numbers, whole numbers for this case that are integers, which is what we call this one, 27 and 33. Did I answer and did I clarify all the questions for that number? Everyone? As you can see, again, try to research more as an additional one for this mock test, the concept of the nesting. The nesting. This is an example of the nested. What's the spelling? The nest. So the spelling, correct spelling. Wait. I forgot the correct spelling of the nesting. Yeah, I think that's the correct spelling. The nesting radical, right? Yeah. Sorry, it's not a direct message. This would be sent to everyone. It's the nesting. Okay, right. Now let's try to move forward to question number 5. Okay, to clarify for everyone. How is one? How the diagonals of a rhombus are 14 centimeter and 48 centimeter. Find the side length of a rhombus. Now, for the case of a rhombus, okay, I'm so sorry. For the case of the rhombus here, everyone, actually the one of the properties of a rhombus is that their side length or the diagonals of a rhombus is perpendicular to each other and they cut each other into half like that one. So because of that concept, we know that this two, example, this is the shorter side, that's 7 because it cuts the 14 centimeter. And then 48 divided, that's 24 centimeter. Okay, then to solve for the question, this is 7. So it's the right angle here. By the way, they're perpendicular to right angle. So we can do Pythagorean theorem for that. 7 squared plus 24 squared is equal to the side squared. Or for those who know the Pythagorean triple, 7 is to 24 is to 25 is a Pythagorean triple. Therefore, the answer for the question is 25 centimeter. Right, because it's a right triangle. Again, property of a rhombus is that the diagonals of a rhombus are actually perpendicular and the rhombus diagonal cut each other into half. So therefore, the answer is 25 units for this question. Are we clear with that one, everyone? Before we move forward to our next problem. Did you see the solution? I'm so sorry. I forgot if ever I've paused the given. Can you see, by the way, everyone? Especially my handwriting, if it's too small, just to tell me. Okay. I get any question for this before we move forward to our next problem? The answer is 25. Okay. That's a case. Let's try to move forward to the next one. None for that. Okay, let's try to move forward to the next question. Question number 7. Okay, how about this one? X squared plus y plus 1 is equal to 0. What is x squared, or what's the value to x cubed plus 2x squared plus xy plus 2y plus x? So that is what is asking the problem here. So for this question, actually, what can we solve or how can we do this one exactly? Okay, x squared is equal to y plus 1. Okay. 2y. Okay, y. xy. Okay. Right. Okay. So if you'll try to look at that one, okay, there is a part here that we know that x squared plus y actually is equal to -1. Wait, but this is a little bit of substitution if we can like have that one. And then we'll try to see if there is a part that we can actually regroup and resolve using the same property. So as you can see here, actually you'll have x squared. Okay, if you try to group together x cubed, let's say x cubed plus xy. Okay, let's try to move that one. So a bit of analysis for that. If you try to solve, or let's try to um, group together what we call this one. We can group together actually your x cubed first, but you need to see the pattern, or you need to see some relationship and some factoring for that one. So actually here, what can we regroup is actually what? We can regroup your um x squared, like that one, or x cubed. Sorry. X squared, not x squared, but x cubed. Wait. Yeah. X cubed, then plus xy plus x. Why did I group that one? That part, okay. I grouped that one because of the fact that I can actually factor out x in this. So if I factor out x in that one, what will happen is you'll have x times x squared plus um x squared plus uh y plus 1, like that. And that part is actually equivalent to x times 0, or that's 0. Again, okay, like that one. Okay, so what will be left here is, again, we group together x cubed plus xy plus x. We group them together like that. And what will be left is 2x squared plus 2y, like that. Okay, 2y. So because of that scenario, everyone, what will happen is that this will become 0 because we have proven that 1 to be 0 on top. So what will be left is this one, 2x squared plus 2y. And then if you factor out 2, that will become x squared plus 2y. Now, if you transpose x squared plus y, I'm so sorry, not 2y, but plus y. But as you can see, if you transpose negative 1 in the original given here, if you transpose negative 1, what will happen is that you'll x squared plus y is actually equivalent to negative 1 if you transpose this one on the other side. So from that, this given right now is 2 times negative 1, and therefore the final answer to the question is equal to negative 2. And that's the answer for that. Negative 2 is the value of the whole expression. Question and clarification for that. Again, question clarification for that one. Okay. All right. I can see that there's none. Again, question clarification, everyone. Okay, no question. Okay, if there's none, again, let's try to move forward to our next problem. Okay, let's try to move forward to our next problem. Okay, how about the next question? So let's try to move forward to our next problem. How about if we do have this situation? Okay, let's try to move forward to question number 8. Sine 30 is equal to sine 1 minus cosine 89. Find the value of the whole expression here. Plus sine 2 minus cosine 88, and so on and so forth. Sine 30 minus cosine 60. Okay, so the main concept for this question is actually, we need to take note that the sine of theta is equal to the cosine of its complement, 90 minus theta, right? So as you can see, we can say that sine 1, because of that concept, we can say that sine 1 is equivalent to sine 89, right? Sine 1 is equal to sine 89. Okay? Sine 1 is equal to sine 89, like that one. Because again, cosine 89, not sine, but cosine 89. So again, the value for that one, again, it's a sine 1 cosine 89, sine 2 is equal to cosine 88, like that one, because, and so on and so forth, until sine 30 is equal to cosine 60. So because those numbers that we are subtracting are actually equivalent to each other, we can say that this one is 0, 0, 0, 0, 0. So basically what will be left is that you have sine 30 times 0, right? Which is eventually will become 0. So the correct answer for this question is actually 0, 0 for that one. Question and clarification for that before we move forward to, again, the next number. And question, clarification for that one before we move forward to the next number. Okay. Okay, none. Okay. If there's none, let's try to move forward to our next problem. Okay. Wait, there might be some questions from the others, huh? Okay. I can see that there's none. Okay, if there's none, let's try to move forward to the next problem. Okay, next problem, question number 9. This one, find or solve for the system of linear or solve for the system of this equation. Okay, so for this equation or system, there's a little bit of a easier way to solve for this. Basically, we can just add up the whole expressions, the three of them. If we add all of them, they'll become like 6a plus 6b plus 6c is equivalent to 11, 19. That's 24, 24. Then all over, we can divide it all over 6, all over 6. So therefore, we can say that a plus b plus c is equal to 4. Right now, a plus b plus c is equal to 4. Question clarification for that, everyone. A plus b plus c is equal to 4. Okay. Okay. Wait, wait. Okay. Right. That will become like 6a plus 6b plus 6c. No question. Yeah, yeah. We're not trying to find the sum of all the variables. We're just getting the value of a plus b plus c. But that's not yet the answer to the question. Right. We are going to use that one to solve solve the system or the equation. Means you're finding the a, the b, and the c. And because of that, a plus b plus c is equal to 4 right now. As you can see, you can subtract 4, subtract this one to the first equation. What will happen? 4a minus a. Okay, let's try to have that will become like 3a. If you subtract this one to the first equation, that will become 3a is equal to 4. And therefore, a is equal to 4 thirds, right? Because again, for a, the b and the c will be canceled out. 8 minus 4 is equal to 4. Again, I subtracted that one in the first equation. Okay, if you don't see that one, I'll try to show it. But I think you passed the heat round. I think you're quite good with that one. So again, you can actually just subtract the first equation just to show for that one. 4a plus b plus c is equal to 8. So therefore, 3a plus b plus c is equal to 4. So we can say that 3a is equal to 4 and a is equal to 4 thirds. Okay, that's the solution for that. A is equal to 4 thirds. Then we solve for the b, the b. So for the case of the b again, what will happen is it will become 3b again. Because if you subtract, a and c will be canceled out. 4b minus b, that's 3b. 11 minus 4, that's equivalent to 7. So therefore, b is equal to 7/3, like that one, 7/3. And then lastly, your c, to solve for your c, what will happen is that you'll be having, again, subtracting, but then still, and so also a and b, and therefore 4c minus c, that'll become 3c is equal to 5 minus 4, that's 1. So c is equal to 1/3 for that. And therefore, those are the answer to the question. 4/3, b is 7/3, c is equal to 1/3, and that will be the answer. Yeah, it's not yet finished. That will become the solution for that. Okay, sige. Okay, again, question clarification for that one, everyone, before we move forward to our next problem. Okay. Okay, if there's no question for that, okay, let's try to move forward to the next problem. Question number 10. Question number 10, what time? Okay, question number 10, we have here, the three sides of the triangle is 13, 37, and 40. Find the area of the triangle. So what is our method to solve for this one? So most of the time we are checking if that's a right triangle. Because if it's a right triangle, we can just do it right away, right triangle. We can just multiply 13 and 37. But I think this is not, because to double check, we can just subtract the highest, 40 squared minus 37 squared. So 40 squared is 1,600 minus 37 squared. If that will become 169, because 13 squared is 169, okay, that will become correct. But since it's not, 37 squared is equal to 37 squared is actually equivalent to, wait. Okay, 37 squared is actually equivalent to 1369. So as you can see, if you subtract this one, that will become 231. 231. Yes, 231. So therefore, it's not 169. Therefore, it's not a Pythagorean triple. So since it's not a Pythagorean triple, this is 21. 21, no. Yeah, 21. It's 21 times 21. Okay. So here, or the 21 times 11. Okay. What we can do next is actually, we can just now simplify the equation. Okay. And then, I mean, since it's not a right triangle, we can do Heron's formula for this. Heron's formula. So how do we solve Heron's formula? So first, we need to find the semi-perimeter, the half of the perimeter, right? We can just add that one up. Semi-perimeter divided by 2. So that's like 40, 50, 90. So 45. And there, to find the area, we can do the Heron's formula. Square root of s times s minus a times s minus b times s minus c. Okay, that's how we solve for the, what we call this one, for the expansion. So as you can see, that will become equivalent to square root of 45 times 45 minus 13 times 45 minus 37, sorry, times 45 minus 40. So as you can see, sorry for my writing, that will become the case. So that's square root of 45 times 45 minus 13. That's actually, this is minus 13. Sorry for my writing, but yeah, that's 2, that's 32. 32 times 8 times 5, like that. So we can actually group them together if you like. Now we can group them together in such a way that we can factor or try to find the factors. For example, your 9. Your 9 will be grouped here, 9 and 5, no? That's times 25. We group together the 5 here and the other 5. Then the 32, we can get the 16. No, 16. So 16 times 16 or 16 squared. So what will be left is, because 32 and 8 is like 16 squared. Okay, so therefore we can factor that one or distribute. That's 3 times 5 times 16. And that'll become like 15 times 16, or let's say 30 times 8, that's 240. So the area is actually 240. Question clarification for that. Oh, sorry for that one. I'm colorblind. But can you see it? Okay. It's not that clear in a set that clear with your case. Okay, I'll try to write in a black pen na lang. Okay. But yeah, Heron's formula. Which part is not clear for that one? I'm trying to change the color from time to time to highlight the changes in there. But yeah, that's Heron's formula. I'm hoping that the Heron's formula is known now for your case because I think that's a grade 6 or grade 7 lesson. Right? You're grade 8 now. So that'll become like 45 times, oh no. That'll become like this case. Okay. But yeah, that's the answer for that. Heron's formula. Okay. Oh, sorry. Can question clarification for that one, everyone, with the solution. Okay. Jaden, is it okay? Can you see it? Nah? So sorry for that. I'm a little bit color blind. That's why I'm not that good in colors. If you can see it, and in my case, it's you can see it, but I don't know with your case. So 45 minus 40, like that. Okay. So yeah. Again, question clarification with that one, everyone. Okay, right. If there's none, let's try to move forward to the next question. Okay. Try to move forward to the next question. Let's say you'll have okay, let's try to have this one. Okay. Next question. Question number 11. So question number 11 will be in relation to your set B. This is set B now. Question number 11 is set B. So your set B is actually involving some problems that are a little bit harder compared to the first set. So let's try to solve that one right now. Set B, question number 11. Try to have that one. How about question number 11? Here we go with that one. Okay, question number 11 asks us, find the minimum value of square root x minus 3 plus 2 square root of x plus 2 and so on. So we're trying to find the minimum value of this one. So actually, in this question, uh, actually, the best way or the best thing that we can solve this is actually we'll use the numbers in between. Okay, because there's like a absolute value. They're like critical numbers like 3, kasi 3, and we have for the case of x plus 2, the critical number for the case of x plus 2 is actually 2, negative 2. Here, that's 3. Now, because of that one, we can say that the numbers can be divided in a number line. The numbers that we can use here is actually like less than negative 2, then you have 3 here, like that one. So all the numbers in between negative 2 and negative 3 will add up to actually 5 because that's basically the distance between them. Okay, x plus 2, if you substitute, let's say 0, that's 2 plus 3, or any numbers in between them, that will become 5. But if you'll check numbers less than, let's say negative 3 for the case of negative 3 here, and the less than of negative 2, they'll become like negative 6, absolute value, plus negative 1. that's greater than 5. That's negative 7 already because it's like the total distance, additional distance from both of them. Same thing here also. If you use 4, that will become actually, no, that's not negative 7 because absolute value, that's positive 7. So as you can see, that will become positive 7 in this scenario. Now, if that's positive 7, we can just add it up. If we use 4, again, like that one, so that's 1. Absolute value of 1 plus 4 plus 2, that's absolute value of 6, and that's still 7. So as you can see, numbers outside of the range of negative 2 to negative positive 3 will be greater than 5. And therefore, the minimum for that one is 5 actually, because whatever number that you'll be using in between negative 2 to 3, their value will become greater than, or I mean, near 5, because it's like the total distance when you're going away from those numbers. And the minimum parts is if you're using the numbers in between negative 3, or I mean, negative 2 to 3, the critical values of this number. So the correct answer is actually equivalent to 5. Wait, teka. What to each other? Wait. Yeah, that should be 5. Actually, that should be 5. That should be 5 for that question. 5. Question clarification for that. We move forward to the next number. Okay, if there's none, okay, let's try to move forward with the next question. Okay, next question. Okay, how about question number? Wait. Question number 12. Let's try to go to question number 12. How about this one? Given that alpha and beta are the roots of the expression, alpha and beta is the roots of the next question. What will be the, okay, given that alpha and beta are the roots of the quadratic equation, what is alpha squared, beta squared? So for this question, actually, we'll be using only the Vieta's theorem or Vieta's formula. So Vieta's formula states that if the roots is given, we know that the sum of the roots alpha plus beta is equivalent to negative of negative b over a. That's alpha, or that's alpha plus beta, the sum of the roots. So the sum of the roots is actually negative b over a, and the product of the roots alpha beta is equal to c over a. By the way, where will we get a, b, and c? Your a, b, and c is actually from the quadratic equation ax squared plus bx plus c is equal to 0. So therefore, for this case, your A is actually 2, your B is negative 6, your C is negative 13. So negative of negative 6, that's negative B over A, that's 2. That's equal to positive 3. So alpha plus beta is equal to 3. And then it will become question number 1 all over again a while ago. So your C over A is negative 13 over 2. And that's it, negative 13 over 2. So how do we solve for this one again? Again, for this, we can use the uh, question number 1 a while ago. So question number 1, we can just square this one both sides. Square that one. Your alpha beta squared will become alpha squared plus 2 alpha beta plus beta squared right now is equal to the square of 3 also. That will become 9. Okay, so alpha squared plus beta squared is equal to 9 minus or 2 alpha beta, which is actually equivalent to negative 13 over 2. So basically what will happen for that one, negative 13 cancel out the 2. So that's negative 13. So 9 minus negative 13, that's equivalent to positive 22. Therefore, the answer to the question is actually positive 22. Now, question and clarification for that one, everyone, before we move forward for this next question. And question and clarification for that one before we move forward to our next question. Okay. If there's none, let's try to move forward with the next number. If there's none, let's try to move forward to our next number. Okay, how about if you do have this set? Okay, let's try to go with this set now. Okay, question number. Okay, let's try to go with question number 13, right? Question number 13. How about question number 13? Here's the number 13 question. Teka. Okay. Question number 13. Yeah. 3a plus 3b minus c is equal to 1. Then negative a plus 2b plus 3c is equal to 3. And 3a minus b plus 2c is equal to 6. Find the value of 3a plus 6b minus 7 minus 7c. Okay. Now, in this question, this is a little bit similar to the first one of the questions a while ago. If you try to like add them up, as you can see, 2a minus a plus 3a, that will become like 4a plus 3b plus 2b minus b, that's 4b, like that. Adding them up, then it's negative c plus 3 plus 2, that's actually 4c again, all over. And that'll become equivalent to 1 plus 3 plus 6, that'll become 10, like that. That's 10. Now, the question is, we're trying to find actually the value of 3a plus 6b plus what we call as 1 plus 2 6b plus 7c. So we can actually get each of the values of a, b, and c for that, or we can try to find a way that we can create this equation if you like. We can do that one also, but sometimes that will be a little bit of a challenging if you do that one, right? So what can we do for that? Oh, wait. Yeah, if we added, wait. If we minus the first equation, no, wait. Is there a chance? Okay. No. I think there's a little bit of a challenging if you do that one. So what we can have is actually, we can have this one to be A plus B plus C is equivalent to 5 halves, like that one. 5 halves or 2.5. That's for A plus B plus C. Okay, so using that one or using that data, we can actually, or yeah, right. We can actually, it depends upon how you will analyze it. You can actually also do it like 2a, right? 2a plus 2b plus 2c is actually equivalent to 5, like that, without dividing it by 2. If you want to use not like non-whole numbers like that. Okay, why did I do that one? Because if you'll try to do it like that way, we can actually somewhat create some equations that will give us the value, which is I see now. Okay, right. Okay, now I can see it now. Sometimes analysis is a given. We don't need even that one. Okay, we don't even need this one. Why? Because we can just add the middle equation and this new equation. If we add the middle equation and that equation, what will happen? Negative a plus 4a, that's 3a. 2b plus 4b, that's 6b. 3c plus 4c, that will become 7c. And then 3 plus 10 is equal to 13. And there you go. That will become the answer to our question. Now, if that's the answer to our question, then that is what you can have in the given. Okay, and again, that's the answer to the question. Letter or 13. Now, question clarification for that one. Okay. Okay, if there's not, okay, let's try to move forward to the next question. Question number 14, right? Question number 14. How about this one? Okay, question number 14. Okay, refer to the figure below. A, B, C, D, and E, F, G, H are two 10 centimeter by 3 centimeter squares. If the overlapping area is 15 centimeters squared, find the length of I to J. So we're trying to find the length of I to J, or AJI, like that one. Okay, like that one. So how will we solve this question exactly? So we know now that we have, or sorry, the total area of this part here right now is equivalent to, what do you call this one? I to J. We can try to connect them. So we know that the total area right now of the figure is 30, right? 30. We know that is a 30, or 10 by 3 centimeter. I mean, the total area of each rectangle is 30 centimeters squared. So basically, this is half. This is like half of the figure, or this will be half of the figure. So as you can see, if because the whole thing is 15, right? 15. So because of that, that's actually it's technically in the half part of our situation right now, exactly half. Now, if we do that one, basically, we know that this is actually what? We're trying to find the length here of J to I, right? J to I. Okay, so how do we find that one exactly? So as you can see here, because it's half, we can say that J, let's say, ha 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 ha. Okay, this is, we know that that's 15, that's base times height, right? Okay, okay, okay. Now, we know, right, that right now, this right triangle here, AB, is actually 3 centimeter. We need this is 3 centimeter, and then that will become like 3 centimeter there, A to B. DC is 3 centimeter also. And because of that, we can say that the height of this triangle, or this parallelogram, because it will become a parallelogram, is 3. So for it to have an area of 15 centimeters squared, we know that the base is 5. This is 5 right now, 5. So since that is 5, okay, this is 5 here, 5 in that given. Okay, we can now just like analyze or try to solve the, wait. That will become equal 5, 5, because 5, this is 3, like that one. But we're trying to find the value of your JI for that matter. So that's 3. We know this is 5. Okay, all right. 5. Wait. Will become half. Will that become half? Wait. That's 3. So we know that the area here on the upper two are equal actually, right? So what we're trying to find is the length there. Okay, now, this is like a little bit of a sketch for that matter, right? A little bit of a sketch for that matter. But if you'll try to move that one, we're trying to find your JI. We can actually isolate and move that one a little bit in this side here, that it will coincide in the diameter here in the other side, so that we will give us the value. Yeah, a base time side. All right, base time side of our parallelogram. So we know that's 15 already. Your height is 3 here. So 5 here, because 3 times 5 is equal to 15. That's how we get the 5 for that question, right? Because again, the area of a parallelogram is base times height. So we know the height is 3. So to make it 15, we need to have it as 5 like that. Are we clear with this? Yes, that's it. That's how you find the value for that. So as you can see, that's 5 already. So with that one being said, we can actually a little bit move the question, or move the given there, so that it will coincide in this part here. Okay, so that you will know this is 5 right now. And then because that's 10, that will become 5 here in the other side. Okay, like that. Okay, we can actually like make it that way so that it will become 5 here in the other side. And as you can see, we can just like find the value of this one right now. Okay, this will become like 3 here. And then since that is actually 7.5 here. Okay, wait. With the base. Okay. We're trying to find the length of JI. Wait. Similar triangles. Will we have similar triangles for this? Okay, J to I will just be equivalent to that. They're just equal. Will it become isosceles? Okay, wait. Okay, that's a bit of a challenging. Okay, wait. For that one, 5. We'll have that one, 7.5. The height here is 3. This is 5 here. Oh, this will be also 5 here. Okay, there you go. Yeah, isosceles siya. Okay, parallelogram, isosceles. That's actually a trapezoid. Wait lang. right angle, angle, same angle there for T, A 5, 5. Wait. 5, we know that's 5 there, 5. No, that's a 3. That's 3. 3, 4. This will become 4. That's 1. Yeah. Okay. Right. So well, this is how we can get the value for this. Now, the answer for GI is actually square root of 10. Now, let's try to have that one again one more time. Analyze it completely. How did we get, or how can we get the value for this? So as you can see again, we'll try to start with the fact that we have 10 by 3 centimeters. So the area of the two rectangles is 30 centimeters squared. So the overlapping part is 15 centimeters squared. Okay, 15 centimeters squared. That means that's actually completely half of the parallelogram. Now we are trying to find your value of your j to I, right? We're trying to find the value of your j to I. So how do we solve for that one exactly? So for this question or for this diagram, that figure that you are forming here is actually we'll be forming some similar triangles, or I mean, yeah, similar triangles actually to be exact. Okay, that's J to I there. And that is actually a little bit of a parallelogram right now, since there's parallel. And that parallelogram is actually a rhombus. But how do we know that one that will become a rhombus? Because of the relationship of the angles that they're forming. So this angle here is like equal to this angle here, like that. And because these two angles are equal to this angle, and this is their parallel, their angles are actually equivalent to each other. Okay, since this all angles here are equivalent to each other, as you can see that these three are actually forming a rhombus, and all the sides here are equal. No? All the sides are equal. Again, we're trying to find your GI lang. Okay, so how do we again do that one? Let's say zoom in the figure here. Let me zoom it in so that we can see for everyone's situation for that number para makita natin and makuha natin yung question dito. So let's try to zoom that one in. Okay, wait. Okay, then we'll try to make it a little bit bigger for that. Okay, here we go with that a little bit bigger situation or scenario for that number. Okay, let's try to make it a little bit bigger for everyone to see right now. Okay, so that we can work on that one more or much properly. There you go. Okay, the figure is there. So as you can see again here, everyone, because of some properties of angles, let's say this is angle A here. Okay, this is angle A. This will become angle A for the vertical angle. Let's try to draw JI, the one that we're trying to find here. Okay, then let's say this is 180 minus A, right? Okay, or I mean, yeah, that will become equal to that. And therefore, this will become A also because of the transversal property. If this is A here, then that will become A here, and this is actually A, right? Okay, now, because of that scenario, we can see that this will also equal to A, right? A, like that. So if you try to have that one that's equivalent to each other, and this two is actually equivalent to each other here, like that. So if that's the case, as you can see, A, this will become like the sum of this two. This will become like 180 minus A. 180 minus A, like that one. They're equal. Okay, and that will only happen for the case of your they will become equivalent to each other right now. And because of that, we can say that that will become a rhombus kasi the angles are actually congruent to each other. Okay, they will become equivalently in cutting that one into half and congruent. So therefore, that will become a rhombus actually in terms of that property because it will create two similar triangles. Okay, they will be creating two similar triangles for that matter. And if they're two similar triangles, they can say that that will be creating a rhombus. Okay, similar ito. And that's because they're similar. I mean, then they'll become this one isosceles. All of this are 5. That's what we have get a while ago. 5, 5, and 5, and 5 here. 5 then dito. Now, because of that, we can now say that if you try to draw, again, what we had a while ago, this will become 3 here. Okay, change natin yung color. There should be 3 in this part here. This is 3, right? 3. The height of that, as what I have said a while ago, that's how we get the 3. So 3 dyan, and therefore this will become 3, 4, 5, right triangle. This is 4. Okay, 4, 3, 4, 5 right triangle. So therefore, we can say this is 1. Okay, so if we have that 1, there's a right triangle in this side that have a side of 1 and a base of 1 and a side of 3. So therefore, to solve for ji, that will become square root of 3 squared plus 1 squared, which is eventually become square root of 10. So therefore, the correct answer for that question is actually 10 for that matter. Are we clear with that one, everyone, before we move forward to our next problem? Square root of 10 is the final answer for that, or for that question. Okay. So if there's none, let's try to move forward. Let's try to make it a little bit faster for this one. Let's try to go to the next question. Question number 15. Some integers are the sum of the power of 3 such that 37 is equal to 3 cubed plus 3 squared plus 3 raised to 0. Find the number whose sum of the power of 3 less than 1,100. So we need to take note of the powers of 3. So for your powers of 3, actually, everyone, we need to take note that the powers of 3, like 3 raised to 4 is already equivalent to powers of 3, right? It will become, no. The question says that the sum, find the number whose sum of the power of 3 is less than 1,100. With one sum, the same power cannot be repeated. Okay. Find the number whose sum of the power of 3 less than 100, 1,100. Okay, right. Powers of 3 less than 1,100. Let me check. Okay, 3 raised to 5 is 243. 3 raised to 6 is 729. Okay, wait. Is there a typographical error for this question? Wait lang. Let me check. The question says that some integers are the sum of the powers of 3. Like 37. That's 27 plus 9 plus 3 raised to 0. Find the number whose sum of power is less than 1,110. Uh-huh. Within one sum, the same power of 3 cannot be repeated. Find the number whose sum of the power of 3 less than 1,100. Wait. I think there's something a little bit wrong with the question. Some integers are the sum of the powers of 3. Like 37 is 3 cubed, 27 plus 9 plus 1. Find the number whose sum of the power is 3 less than. Find the number of numbers, I think, whose sum of the power is 3 less than 1,100. I think that's what we're trying to find here. We're trying to find the sum of all the value or how many numbers are there that can be expressed as the sum of the powers of 3 less than 1,100. So that is actually what is asked in this problem. Yeah, I think. Okay, so as you can see, we can actually use 3 raised to 6 as the highest one. 3 raised to 6, 3 raised to 5 plus 3 raised to what's it called? 3 raised to 6 is the highest number that we can use. 3 raised to 6, 3 raised to 5, 3 raised to 4, 3 raised to 3, 3 raised to 2, and then 3 raised to 1. No, that's not plus, but actually like let's say that's find the number whose sum. I think find the number or are how many numbers can be expressed as a power of 3 less than 1,100. That's I think what is asked in this question. Okay, a little bit of a typographical in this event. So for this one here, we need to take note again. The highest number is 3 raised to 6. Less than 1,001 is 3 raised to 6. Because 3 raised to 7 is already um 2,187. So 3 raised to 6 for that. Then we can use 3 raised to 5, then 3 raised to 4, 3 raised to 3, then 3 raised to 2, then 3 raised to 1, then 3 raised to 0, like that. We can use all of them. Okay, as you can see for that one. So for the case of 3 raised to 6, there will be limited values that we can use. Oh, no, no. Can we pair them up? Again, for the case of 3 raised to 6, we can actually have limited values for that matter. Okay. But we're trying to find how many are there, right? 729 divided by 3, 127. Wait. So we're trying to find how many numbers are there. Oh, wait lang. Or the question is not stated properly. Let me check. Let me check for that one. Give me a few minutes. Okay, wait. Powers of 3. Okay. Powers of 3. 3. Okay, let's try to see. For the case of the powers of 3, yeah, we need to take note of the pattern for this one in terms of the powers of 3. Okay, because I know that all the numbers can we write, technically, can we write all the numbers in terms of power of 3? Let's say 1 we can have, but 2 we cannot have it. I think that's the solution. 2 we cannot have it as a power of 3. No, we can have kasi different. No. Okay. So it can we cannot actually like use the powers of 3. We're just using one or two ones lang for ratio 3. 1 could be done, 2 is not. Then we can use 3. 4 is possible. 5 is not possible. 6 is right. We're actually trying to find out the pattern for that one in terms of the powers of 3 or summation of powers of 3. That's actually what we're going to do here. As you can see, if you'll try to analyze it, class, we can actually we can start with 1, right? Integers. Okay, less than sum of the power of 3. Okay, I think how many numbers or integers are there? Whole numbers are there. So 1 is possible. Okay, because we can do that one. 1, 3 raised to 0. For the case of 2, we cannot create dalawang 3 raised to 0, so isa lang. So we cannot make the 2. But for the case of 3, we can. 3 raised to 1. For the case of 4, we can add up 3 raised to 1 plus 1. For the case of 5, we cannot do that. Okay, because that is no 3 raised to 1 plus 2. Okay. For the case of 6, we cannot do it also. Okay, because 4 is the possible value lang for that. Okay. For the case of 7, we can do 7 because no, 3 plus 2, no, hindi na pwede yung 7. Then after that one, we can do the 9. 8 is not possible also. Then the one that we can do is 9 for that. So as you can see, there are some numbers that will be skipping out of that. Okay, we're trying to find how many is that one exactly. So for that one, 3 raised to 1, powers of 3. After that, we need to know lang how many cannot be used after the situation or after the rest of the situation. So as you can see, 10. We can have 10. Uh, can we have 11? So that's 3 plus 9. That's 12 already. So we cannot have that one. Wait. Okay. This question is a bit tricky. And I'm not sure if that is what is asked in the problem. Difference. Okay. Sum. Okay, wait. Okay, wait lang. Wait. Mhm. Wait. Okay, wait. Let's try to go back with this one in a while for that question. I think there's a little bit of a typographical error in this given. because again, the answer is 127 in the mock answer key, but there's a lot of other numbers that you can express. So basically, I think we're trying to solve here the number, but I'm trying to confirm it first if what is asked for that one. We'll try to go back with number 15 in a while. Okay, let's try to move forward first with the other numbers so that then we'll try to go back with the number 15 later on. I'm thinking about what is the solution for that one exactly. Okay, so let's try to go first with number 16, and then we'll try to go back with the number 15 a while next time or a while ago, not next time. Okay, now let's try to have this one. Okay, so for the number 15, um wait lang. Okay. Right. We'll try to have this one. Given that 1 over x plus 1 over y is equals to 11 and so on, we're trying to find what's the value of x plus y plus z in this given. So for this question, it's a little bit similar to the previous set, actually. We can actually add them out, okay? Let's try to go with this one. We can add these equations out. If we add it 1, we'll be having 2 over x plus 2 over y plus 2 over z, because that's twice of each one, is equivalent to what? It's equivalent right now to the values. Wait. The previous question, we'll try to go back with the previous question. No worries for that one. I think there's a little bit of a typographical error for that previous question, number 15. And we'll try to go back with that one in a while. Okay, just clarifying what should be the final answer or what should be the final solution for that. Okay, but we'll try to go with number 16 first. We'll be adding this one here, 11, 6. Based on the answer key, it's 127, but we'll try to double check it in a while. Now here, if we add this one out, that'll become like 26. Let's try to finish the solutions first, the previous or this next questions, then we'll try to go back with that. So this one here, if we add this one out, that will add up to 26 right now. And as you can see, if you divide that one by 2, that'll become 1x plus 1y plus 1z. A little bit of the same concept a while ago. Is equal to 13, like that. So if you do that one, what will happen is that we can actually get the values for s. Example, if you wanted to get 1 over z, 1 over z is actually equivalent to we can subtract this equation to the first equation, and then we'll see 1 over z is equal to 2. Therefore, z is equal to 1 half, like that. Okay, then using the same equation, the one that we have added up, what will happen next is we subtract this to the middle equation. You'll be having 1 over x is equal to 13 minus 6, that's 7. So therefore, x is equal to 1 over 7, like that. Okay, then after that one, what will happen next is we'll try to do subtract it from the third one. What will be left is 1 over 9 is equal to 13 minus 9, that's 4. So therefore, your y is equal to 1/4, like that. Now, if you wanted to solve for the value of 1 over x plus y plus z, that's equivalent to the sum of these two, 3. That's what will become, that's 1 over 7 plus 1 over 4 plus 1 over 2. LCM natin yan, that's equivalent to 7 times 4, that's 28. So that's 28, that's like 4 plus, okay, disregard this one, sorry for my writing. 4 plus, let's say 7 plus 14. So therefore, the answer is like equivalent to 21, 25 over 28. And that's the answer for question number 16, 25 over 28. Question clarification for that one before we move forward to our next problem. Question number 28, or that's number 28. Okay. Okay, I can see that there's not. Let's try to move forward with the next part. Okay. Now, let's try to move forward with the next one. So for the next question, we'll try to go, it's 2 raised to 3, 2 raised to 7. Oh, that's a solution for that. Okay, right. Right. Okay. Now, let's try to go back with number 15. I know now the property for this one and how can we solve this one. So the correct answer is really for number 15 is 127. But how do we solve for that one? We need to see the pattern. Okay. Now, for the numbers, okay, if you'll try to look at that one, the numbers that we can use is actually again 1, 2, what we call as one. We can use, if you'll try to see, we can actually form for those number less than 3 raised to 1, right? There's only like one number that we can use, right? One number that we can use that will become equivalent to what? For the case of 3 raised to 1, the only number that we can use for this is actually uh one way lang. 1. We can express as 1. Okay. But for these numbers less than 3 squared, like that, 9, we can express 1, 3, then what we call 1, 3, 4, and 9, like that one. 1, 3, 4, 9, and then 10. Sorry. 1, 3, 4 lang actually, sorry. 1, 3, 4. For those numbers that we can express again, that will become 1, 3, 4. Okay. 1, 3. For less than 9, that's 1, 3, 4 only. Right? 1, 3, 4 only. Yes. Wait. Tama ba? First 3 squared, that's actually numbers that we can express. If it's 3 squared, wait lang, 3 raised to 1, try to have this one, 3 raised to 1, those numbers that we can express as a power of 2 is actually equivalent to, we'll say 3, for those numbers that less than 3 raised to 1, or 3 raised to 1 and up, there's actually dalawa, 1 and 3 only, right? 1 and 3. Is there the 2? Can we have 2? Wala. Okay. Then for the case of those numbers less than 3 squared, which is 9, we can have 1, 3, 4, 1, 3, 4, and what we call as 1? 1, 3, 4, and then what we call as 1? 1, 3, 4, then 8. 1, 3, 4, then 9, like that. 1, 3, 4, and 9. Okay, 3 squared. For the case of 3 raised to 3, the pattern is actually like that one. So how many numbers can we create? And also 10. 1, 3, 4. Then you have like 9, 10. 2 squared, 2 raised to 7. And 7, 2, 9 lang yung okay. 1, 3, 4. Kasi the numbers that we can use is actually like 3 cube until 3 cube only for this number. So 27, we know we can create 27. Then after that 1, we can have 9 plus 3, that's 12. Then after that 1, 9 plus, what we call as 1. For the case of 3 cube until 3 cube, we can have 9 plus 12. Then after that 1, 27 na lang. 27. So it's like 1, 2, 3, 4, 5, 6, 7. Then that is actually 2 cubed, 7, like that. And so on and so forth. As you go higher now with this one, the pattern is actually giving us is that the number that you can create after the numbers like this one, 3 raised to 1 plus 3 raised to 2 plus 3 raised to 3 plus that until 3 raised to 6. Since we can use until 3 raised to 6 for those numbers less than 1,100, that means that we can only select actually 2 raised, the 1,100's case, that's actually until 2 raised to, or 7 to 9, 3 raised to 7 only na lang. Okay, 3 raised to 7 lang. So because of that, that's the highest number that we can use. And then to solve for how many numbers that we can create out of that, that will be like in the pattern 2 raised to n minus 1 lang. Kung ilang numbers that we can create using the digits 3 raised to 7, that's 2 raised to n minus 1. Since less than tayo ng 1,100, it should be less than 3 raised to 7. The only numbers or the following numbers that we can create, the highest number that we can add up para maging less than what we call as 1. Wait lang. 2 raised to n plus 1 minus 1. The only number that we can add up, but that's less than 1,100, is actually 3 raised to 6 lang. So therefore, the pattern of that is 2 raised to n plus 1 minus 1 now, which is 2 raised to 7 minus 1. That's why the answer is actually equivalent to 127 numbers lang. 127 numbers. And therefore, that's the answer for that question number 3. 127 numbers only. Okay, because the pattern is again creating or until what we call as 1, 2 raised to n numbers lang. pwede natin makuha to add up as a power of or a summation of the powers of 3 only until 2 raised to 7 lang tayo for that matter. So that's why it'll be having 2 raised to 7 minus 1, which is actually equivalent to 128 minus 1. That's the number of things that we can use for that. Question clarification for that one before we move forward to the next question. Okay, next question. Cube, 2 cube. Okay, if there's none, let's try to move forward to question number 17. Okay, let's try to have this one. Given that A, B, and C are all prime numbers and AB times A minus C is 1003, what is equivalent of what's equivalent to B plus C minus A? Okay, these are prime number. And for the case 1003, is 1003 a prime number? Okay, if it's not a prime number, then we need to find the factors for that 1003. But it's a little bit hard to find. But actually, 1003 is divisible by 17. Pero it's a little bit hard to find. How do we like check if it's divisible or not? So we can just like square root the 1003. So the approximate square root of 1003 is like 30 something, right? Because it's less than 31. It's in between 31 squared and 31, or square root or 31 and 32, because square root of 31 squared and square root of 32 squared. So therefore around 30. And you double check all the numbers, all the prime numbers. Okay, sorry for writing. You check all the prime numbers less than 31. And if you'll check that one, you'll divide it because there's no exact pattern for that. If you'll try to divide that one, and there's a possibility that those are the factors for that. As you can see, it's divisible by 17. It's actually 17 times 59 only. Now we're trying to find the value of this one. A, B, and C are all prime numbers. Okay, prime numbers. And take note, if we'll be having A, there are two cases for this one. A minus B, let's say an A minus C. That one, minus C. So the possible cases for that, let's say A minus B is the bigger one and A minus C is the smaller. We're trying to find the value B plus C minus A for this situation. We know A is the largest among them. So we can have like actually 17 and 59 for that one. Or pwede rin 103 and 1003 and 1. But if we'll be using 1, the only two consecutive prime numbers is actually 3 and 2. And take note, we cannot use, if these are prime numbers, we can say that your A, we cannot have two prime numbers that are, what we call this one. The sum is equivalent to, wait, 59, 1003, the product of 1003 is actually 59 times 17 times 59, right? So if the numbers are prime or odd, both of them are odd, we can say that if both of them are odd, then we can say that your A should be equivalent to 2 for this one, for them to be a prime number. Okay? Again, why did it happen at 1? Your A should be a prime number and B and C are prime numbers for this equation. So again, the best way to check for that one, if it's divisible by 1003, find the square root of 1003. And as you can see, that's 17. We can actually have 17 and 59 for that. 17 times 59. But again, we have possible powers of 3. But take note, we have only two ways for that, 17 and 59 or 1 times 1003. Either way, they are both odd. So for them to be both odd, take note, prime numbers are almost all odd. So dapat A minus B and A minus C, your A should be equal to 2 for that. That's the only case. Your A is equal to 2. Why is that? Because if A is equal to 2, A minus B and A minus C will be both odd. If not, then they can never be odd. So because of that, we can say that since all of them are prime, we can do that one. 2 minus B times 2 minus C right now is equivalent to 1003. So there's like limited possible values for that one. If you use 17 and 59 by transposition, your B here will become equivalent to if 17 and 59. Right. If it's 17 and 59 like that, what will we have is transpose. That will become your B is actually equivalent to if this is 17 and 59, your b will become equivalent to what? Or negative. No. We need to make it negative because so that your b will become positive. So your b will come to 19, and your c should be equivalent to 61, like that. And they're both prime. And that will be possible, right? That will be possible. The other case is that we'll have -1 and -1003. So if it's -1 and -1003, okay, interchangeable ito. B and C could be interchanged actually. So B will become equivalent to, by transposition, 3, and then 2B minus what? 2B, 2 minus B. And this will become like 2 minus C, right? If we transposition, your C will become equivalent to 1005. And C is not a prime, not prime. So therefore, the only possible values of B and C is 19 and 61, both prime. And therefore, B plus C is only equivalent to, if we add this one up, that's 80. So therefore, B plus C minus A is only equivalent to 80 minus 2, which is equivalent to 78. So the correct answer for this question is actually 78. Question clarification for that before we move forward to our next problem. 78 for that number. Again, question clarification for that one before we move forward to our next number. And question clarification for that one before we move forward to our next number. Okay. Okay, if there's no question, let's try to move forward to question number 18. Find the value of this expansion. Right, so this is a little bit of a tricky part, but what can we do for this one is actually we can multiply. Let's say, okay, we can pair them up if you like. As you can see, the negative here are the following. Okay, right. So what can we pair? Right. Okay, you're right. 13. Okay. The 13 and the non-13, actually, we can pair them up. So we can actually choose which one will we pair. And the better one actually is that we'll be having, as much as possible, two different values for this one, minus ito, 14. So I think that better one is that we're going to factor out the negative. Okay, that's 15. Okay, right. The better pairs are the following: the one in the middle and the one at the latter part. Because if you pair this two and the other side, and then you'll have like, we group together this part. Okay, we'll try to rewrite this one. Square root of 15 plus square root of 13, 14 plus square root of 13, like that one. When we group together these two, okay, regroup them, then multiply it by into square root of 15 plus square root of 14, like that one, minus square root of 13, like that. Can group them together like that. Then multiply this two. We can regroup this together and factor out, let's say, negative of 15, or let's say regroup, or we'll try to regroup actually, right? Regroup actually this one. So what do I mean by that one? Okay, because we can factor out actually, or we can put the 13 in front because it's positive. Then like 13 minus, square root of 13 minus, we factor out here the minus in the first one. That's minus square root of 15 minus square root of 14, like that one. And then the one that will be multiplied to it, sorry for my handwriting, and there's no space, that's square root of 13 plus square root of 15 minus square root of 14, like that. So as you can see, we can do a plus b times a minus b. So become like square root of 15 minus square root of 4 plus square root of 14, quantity squared minus 169, right? A plus b times a minus, no. The square root of 169, which is equivalent to 13. 13 for this second level. Like minus 13, right? Minus 13. Times, what will happen here is that we'll be having like 13 minus square root of 15 minus square root of 14 quantity squared for the second set. Quantity squared like that. That will become the next part. I'm so sorry for my handwriting, by the way. Next one. Okay. After that part, sorry, we're not yet done for that. What will happen next is that we can actually tama. Okay, that's an easier one. Okay, we can actually now get the value of the next part. So as you can see, we can actually expand this, and that'll become like square root of 15 plus 14. When you square that one, it'll become like 29 plus 2 square root of 15 times 14, which is eventually will become equivalent to 15. 15 times 14, square root of 15 times 14 is equivalent to, oh yeah, square root of 210. Okay, which is square root of 210. There's no 7 times 5. No, 7 times 30. Yeah, there's no factor for that one. So square root of 210. Yeah, square root of 15 times 14 or 210. 2 square root of 210. 210, like that. 210. Then minus 13. Right, minus 13. Then on the other side, what will happen is like you'll have 13. Okay, sorry for my handwriting again. What will happen is like you'll be having 13 minus the square of this, which is negative of 29 minus 2 square root of 210. It's the same thing actually, but this time it will become minus like that. As you can see, what will happen is that we can now subtract and combine 29 minus 13. That's actually 16 plus 2 square root of 210, like that, times what will happen to the other side. 23 minus 16, that will become like 202 square root of 210 minus minus 16, which is a plus b times a minus b again. So as you can see, that will become like 2 square root of 210 quantity squared minus 16 squared will be what will happen. So that's basically 4 times 210, which is 840, minus, not yet, minus, okay, minus what? Minus 16 squared, which is equivalent to 16 times 16. That'll become equivalent to so was a 256. 256. So therefore 810 or 840 minus 256, that'll become 584. So the correct answer for this question is actually 584. Question and clarification for that before we move forward to our next problem. 584. And that's the whole solution for that. By the way, again, this is not like first layer, then second layer. A little bit of a multiplication of your radicals. Get question clarification for that one before we move forward to our next problem. Okay. If there's none, let's try to move forward to the next number. Question number 19. Find the units digit of, this is 3 cube, I think. No, that's not 3 squared. That's 3 cube. Find the units digit of the expansion of this given. 1, 3 is 0 until 3 squared, like that one. So powers of 3 actually, adding until 3 raised to 2014. So for this one, we need to take note that the powers of 3, we need to take note in the one in the middle. The powers of 3 are 1 plus 9 plus 7. The units digit, 27 plus what we call this one? 81. No? 1, 3 is 0. No, no. Disregard the 1 first. Let's try to check the pattern. Disregarding the 1. Okay, there's a 1. Okay. Plus 2, that's 3 raised to 0. Oh, why is it that 3 raised to 1? Okay, right. 3 raised to 2, that's 9 plus 7 plus 81, 1, then that's 3. So the pattern repeats every like this one, disregarding the 1 first. So starting with 3 raised to 2. So that's the sum of this is always equivalent to 0, right? 0 plus 2014. Take note, we started with 2, right? We started with 2. So 2014 minus 2, that's 2012 plus 1. There is actually 2013 numbers. No, or disregarding the 1, there are 2013 numbers for this. So 2013 divided by 4, right? Divided by 4, that's actually remainder 1. So therefore, there's a last number there, 3 raised to 2014, that ends with 9. So what will happen is like you'll have 9 at plus 9 here. All of them are 0 in the middle, then plus 9, then there's a 1. So therefore, inside here, 1 plus 9 will end up with 0. So the whole thing here in the middle will just end up with 0 as your last digit. Wait, 0 ba? 9. Wait. First pattern, 2013, right? 2013 divided by 2014, the pattern is like, wait lang. 2014, the last one, it's remainder, no, that's remainder actually 3, 2 times 4, wait, 3, 1, 2014 divided by 4. No, sorry. There's a last one. 2014 divided by 4, that's remainder 2. Yeah, that's 9. Okay, that's actually 9. 2012, 2012 is 0, or that's 1. 2013 is 3. Okay, the partnership is 74, so 9. So 9 plus 1. Okay, I think there's a typographical error. There should be 3 raised to 1 also here. But I think hindi nadala. Kasi that's why the answer is actually 7. But actually, if this is the question, the answer should be equivalent to 1 plus 9 is 0. So 2 times 0 plus 1, that will become 1. 1 should be the answer for this question, actually. 1. And that's the answer for this problem. So therefore, okay, I don't know. Did I share the screen for that? Okay, that will become the answer for this. Again, because the pattern repeats every 4 times, I think there's no number. Okay, but wait lang. Okay, let's try to clarify this one because I think there's a lot of typographical error. Based on the answers, the answer key, that should be 7. Okay, so because of that, basically, the one thing here is actually we need to consider is that this is actually 2 times, I think 3 raised to 0 to, plus 3 raised to 1, plus 3 raised to 2, plus 3 raised to 3, plus that, plus 3 raised to 2014. I think that's the real question for this. Then plus 1, like that. Okay, so as you can see, again, the pattern repeat every 4 times. Okay, every 4 times. Then if the pattern repeats every 4 times, that will add up to 0, right? There's 3 raised to 1 here. Add up to 0. So since it's add up to 0, we'll consider the last 2 digit. Okay, that's 3 raised to 2013. And then that's 3 raised to uh 3 raised to 2014, the latter part. So that'll become like 2. These are all 0. 3 raised to 4, 0 kasi 1 or 3 plus 9, that's 12, plus 7, that's 19, then plus 1, that's 20. So an absolute 0 every 4 times. So there will be the 2013, 2014, that's like 1 plus 2013, 3 raised to 1, that's 3. 2013 ends with 9, like plus 9, then plus 1. So as you can see, this is 13. 2 times 13 ends with 3 here, plus 1. So therefore, that will be ending with 7. So the correct answer for that one is 7 based on that correct question. That should be the correct question for that. Now, question and clarification for that one, everyone, before we move forward to the next number. Okay. Try to move forward to that question before we move forward to our next number. Okay, if there's none, let's try to move forward to the next number. Question number 20. It is known that 2x plus 3y is equal to 6. Find the sum of integral solutions of y if x is from 110 to 111. So as you can see here, how do we solve for this question? We need to basically have y. We can distribute y is equal to negative 2x plus 6, like that, by transposition. By dividing it by 3, that will become negative y is equal to negative 2 over 2/3 x plus 2, like that. So we know that we need to use x to be divisible by 3 for this one to be a whole number. Okay, for this one to be a whole number. So therefore, what are the numbers that we can use for x? The divisible by 3, that's 1002, 105, 108. So for this one. So your y are fx is equal to 102. 102 divided by 3, that's 34. So negative 2 times 34, because 102 divided by 3, that'll become like, or we can basically, summations of y for this one. we're going to add up summation of y so that it will be faster for us. What can we do for that one is actually we're going to just find out that's 34. We know that's 34. 2 times 34. Okay. 102. That's, I mean, negative x over 3 right now. Because of that, that's 34 here. It'll become like 35. That'll become like 36 so that it will be faster for us. So negative 2 plus 34 plus 2, or we're trying to find the summation of y for this situation. So we can just type like negative 2 times the summation of 34, or the summation of negative 2 from this. So we can have that one. 34, 35 plus 36. Then take note we're adding 3 na 2 plus 6. So that because we're adding tatlong 2, so that's plus 6. So that's negative 2 times 35 times 3, that's 35 times 6. We can actually have 35 times 6 na lang. So 35 times 6 is actually equivalent to 35, 70 times 3. That will become equivalent to 210. So negative 210 plus 6, that will become equivalent to negative 204. And that's the answer for that question. Now again, question clarification for that one. Question clarification for that one before we move forward to our next problem. Yeah, the correct answer for that one is linear Joe-Pantin equation, negative 204. Okay. If there's no question, let's try to move forward to question. Let's see question number 21. Let's try to move it faster because I think we don't have enough time to finish this all. So we'll try to finish this all as much as possible. Medyo we'll be going a little bit in extension for that one. So here, how many dices are needed to be thrown such that the probability of offering 1, 4 is greater than 2 over 2. So the question is, how many dices are thrown? So the appearing of 4 will be greater than 1/2, 1 over 2 or 1/2. So we wanted to have that one. So first things first, we'll try to check. If there's one die, that's 1 out of 6. If there's 2 dice, how many ways for that one? That's actually like uh, at least appearing 1/4, right? 1/4. So if it's 2 dice, like say that's either what? One of them is 4 is greater than 1/2. I think 1/4 is 1 over 2. That's actually like 2 out of 36, 2 out of 36, like that one. Right? 2 out of 36. Okay, that's 2 out of 36. If there's 4, 1/4 for that one, that's like 3 out of, or that's 1 over 12. Wait lang, it's getting smaller and smaller. I think when you say appearing 1/4, I think that it means that, wait, 4 times 6, that's 24. Teka. Appearing 1/4. For the case of one die, we need to check. We need to have a little bit of a guess and check for that one. Take note that we wanted to appearing 1/4 is greater than or equal to 4. So if that's 4, I mean, the combination will be like this. This will be like 4, then 2, 3. Other numbers like that. Other numbers for this one. And we wanted it to be over 6. How many 6? Depending upon how many 6 is given. So if example, if it's 1/4, that's like 1 out of 6. If this like 2/4, that will become like 5 over 36. That's 5 over 36 because it will be multiplying below. Okay, another 5 ways for this one. That's actually 25 out of uh 216. So we're trying to find the first one. It will become greater than 1/2. So this is 25 over 216. I think take note, this is one way only because it will have 4 there. This is one way for that first 4. Again, this is the solution for that. Okay. All right, a little bit of a guess and check solution for that one. Again, for this, we are going to find, oh no, wait, what's happening? Okay, we're going to find the, okay, where's the solution? Wait. Did I move that one? Okay, we're going to find the time na maging greater than 36 siya. So for this one here, or 1/2, okay, to be exact. So for the case of 4, that's 1/6. If it's 1/4, 1 dice, okay. Try to show na lang 1 dice for die. So if it's 1 die, 1 die, that'll become like 1 out of 6. If it's 2 dice, that will become equivalent to 4 then 5 ways for the second die, times 2, because that's interchangeable, all over uh 36, like that one, 36. So that's like 4 na sa first die, that's 1 way. Okay, 1, that's 5 ways for the second die, times 2 because interchangeable pa sila, then that will become equivalent for the first die. So that's 10 out of 36, like that one. Or that's not bigger than 36, or that's not bigger than 1/2. If it's 3 dice, that will become like 25 times 3 factorial over 36, or no, 216. So if that's the case, as you continue with that one, we can actually just get the first one that will become greater. So if we'll try to say that one and continue, you will see that in the fourth die, it will become greater. This one is not that getter yet, later, because this will be like, what? This is 6 times, this will become 6 times 6 times 6, cancel out this one. That's 25 over 36. Wait lang. 3 factorial. 1, 4. 3 dice ba? 25 over 36 is already a correct answer for that one. 25 ways. 25 ba? 5 times 5. Appearing 1, 4. That's 25 ways. Then you can have times 3 factorial. No, 3 ways lang pala dito. Sorry, not 3 factorial ways. So this is actually 36. 36 times 2 pa tayo. That's 25 over 72 lang for this one. So as you can see, it's quite near lang for that one. Okay. And then you'll be having, until that one's a fourth die, we'll be having like this one. So 4 dice now. The number of ways that we can have that one is like 5 times 5 times 5, which is 125. 5 ways for 5 times 5 times 5 for the 3 other dice, times what? 4 factorial. 4 factorial. Your 4 could be anywhere pa. That's 4 ways still. Times 4 ways now. All over 6 times 6 times 6 times 6, because there are 4 dice now. So if you try to simplify this one, this will become like 125 over 216. And that's greater than the half. Okay, 216, no, that's 4. 125, 125 over 216 times 2/3, like that one. So that's actually 250 over what? 250 times 3, that is actually what? 18. 18 carry 1. 216 times 3. Yeah, that's, you got 216 times 3, that's equivalent to 648. Wait. Wait. Find number without reading 1, 4. 1, 4 is greater than 1 over 2. Okay, 1 over 2. So it's greater than 1/2. 250 ba? 5 times 5 times 5. 1, 4. That's 250 over 648. 25 over 72. How many dices are needed? Teka. 5 times 5 times 5 times 5 over 666. Wait lang. There's a little bit of a challenge for that one. Okay, wait. 4 divided by 500 divided by 6 times 6 times 6, 6. Wait. Okay, no, it's not 4. Greater than 1/2. Wait. How many dices are needed to be thrown such that the probability of appearing 1, 4 is greater than 1 over 2? Appearing 1, 4 is greater than 1/2, right? So I think for this one, if it's at least 1, 4, wait. That's already greater, so 10 over 36. Teka. 1, 4. 4. Wait. The question is a little bit tricky for this one. Mhm. 5, 6 raised to n. Yes, but you need to take note that it will be permuting that one. Okay. Yeah, greater than one. At least it did, yeah. take note that we're getting that will not work because the question is that 3 factorial for that one because you're permuting the 4 only. So that's 3 lang. Yeah, 3 lang, 3 only in the numerator because you're permuting 3 ways for the 4. Your 4 could be first, second, or third, like that one. The question was, J for the case one, can we have no, we cannot have that one. If it's actually appearing at least, if it's at least one, then it will work yung 5, 6 raised to n. But if it's not at least one, then we can have, I think maybe the question is about having at least one here. Kasi the question states right now that appearing 1, 1, 4. Now, if it's appearing 1, 4, it means that greater than 1 over 2, greater than 1 over 2. So if it's appearing 1, 4 only, exactly 1, 4, that will not be working in 4. I think the question was if it's appearing, what we call this one? At least 1, 4. If the question is appearing at least, then that's a correct answer, I think. So there's a little bit of typographical in this question. Maybe the question wanted us to ask at least 1, 4. So if it's at least 1, 4, that's correct, right? If it's not 4, or there's no 4, that's 5, 6. That's already greater. The first one pa lang is already greater than 1/2. So I think the question is really not at least, no? Because if at least 1, 4, that's 5, 6 already for the first one. But here, exactly 1, 4 kasi. Exactly 1, 4. So if it's like 4, again, if it's 4 dice, the question is not correct also because how many dice are needed to be thrown such that the probability of appearing 1, 4 is greater than that. So that's like 4, then blank, 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 blank. If it's 4 dice right now, that will become like 4, then 5 times 5 times 5. That will become 125. No, 4 dice, right? Over 6, 6 times 6 times 6 times 6. And then this is times 4 ways because this is one way here, times 4 ways because you can put 4 in one of them there. That's why it's 6 ways for that one. So if that's the case, if the scenario is it less than, that's not. 125, that's 500 over 1,296. And it's still not greater than 4. So the question is not 4 dice. Kung 5 naman, that's 5. That'll become like 5 raised to 5 over 6 raised to 5. And that's the case. I think the answer should be 5 dice. Because if it's 5 dice, that'll become like 5 raised to 5 over 6 raised to 5. That is actually the correct answer. It should be 5 dice. Okay, it should be 5 dice. Because 6 raised to 5 right now is equivalent to 776. 5 raised to 5 is actually equivalent to 3125. Oh no, it's still not yet. Wait lang. 5 raised to 6. Right. Wait. So the general pattern right now, if you try to look at the pattern is like 5 raised to n minus 1 all over 6 raised to n times n minus 1, right? Or n, yeah, n times n should be greater than 1/2 like that. So if that is the case, when will be that be greater than 1/2? If you look at the pattern, that's a pattern of the number of dice. If it's 4, right? Okay, if you try to think about it, that's like 5 raised to n minus 1 divided by 6 raised to n minus 1. Then you're multiplying it by n. Now, when will that be? No, n lang. The question is, when will that be greater than 6, no? Or greater than 1/2. So if you'll try to divide it 1, that'll become like 5, 6 raised to n, right? Then times 1 over 6 raised or n times 6 raised to n should be greater than 1/2. Okay, that's a question. When will that be greater than 1/2? So if that is like 1, 5, 6 times 1 over 6, that will not be the case because the numbers here is still greater than that. So I think, will that be possible? That's, I don't know. N over 6. This is actually n over 6, not n over 6 for that matter. Right? This is n over 6. So 5, 6 raised to n times n raised to 6 should be greater than 1/2. Okay, so for that one to happen, actually, we need to take note that if it's 4, 4 raised to 6, That's 2/3. Okay. If it's 3, oh, in this situation, kasi nag-thought. Because we know that 5 raised to 6 is already raised to n. 5 raised to n over 6 raised to n is already greater than 1 half. Therefore, we need to make sure that this part should be greater than 1 half. And that will become 4 raised to 6 only. But will that be happening talaga? Okay, kasi 5 raised to n. Okay, no. 5 raised to n minus 1 pala ito. Minus 1 is already greater than um 5, 6 raised to n will become greater than already for that one, then 1 half times a number greater than 1 half. But I think that will not be workable for that one because we're going to multiply them. So that's actually a work in progress talaga. Okay, let's try to go back with that number 21 later on. Or there's a questionable answer. Actually, the answer 4 is not the correct answer. So maybe there's a little bit something wrong in this question. Okay. So that's why hindi siya correct yung question for that one. Let's try to move forward with number 21. Let's try to finish up na lang what we can finish up for this one. Next question. We'll try to extend a little bit to everyone, but I think that will be until 3:30 only. Let's try to move forward with this next number. How about question number 22? Find the value of 3 raised to 4 squared for that one. So again, the given, or we are actually had what we call this one, na binigyan tayo ng pattern for this one because 3333 is 10 raised to 9 minus 1. So it's 10 raised to 9 minus 1 plus 1 right now all over 3, right? The 3034 is raised to 1 all over 3, like that one. So as you can see, that's like basically 10 raised to 9 over 3 na lang ito squared. So that's how we find the value of the situation. Again, to solve for this one, basically again everyone, that's 3 to 3 is this one. So that's 10 raised to 9 minus 1 all over 3 plus 1 like that. So we're trying to find, we need to square that one. We need to know how to square that one. So if you do that one, what will happen is like you'll be having equivalent to 10 raised to 9 minus 1 plus 3 all over 3 quantity squared like that. And that's what we're trying to find here. Now, if we try to simplify that one, it'll become like 10 raised to 9. Or we can just square this on both sides. But yeah, that'll become 10 raised to 9 plus 2 all over 3. Then a squared. Okay. Now, if you do that one, that'll become like what? 10 raised to 18. Okay. 10 raised to 18 plus 2 times the product of this 2. 2 times 2, that's 2 squared times 10 raised to 9 all over 9. Then there's a plus 1 on the latter part, like that one, plus 1. So as you can see, wait, 334, 334. Yeah, no. It should be in the plus 1. There you go. The plus 1 should be included in the numerator. So that's 33339999. That will become plus 1. So as you can see, we're trying to find now the value of your answer. It'll become like 10, 10, 9, 9, 9, 10, 8, 18, 18, and so on. So 10 raised to 9 will become like factor of 10 raised to 9. Wait lang. Okay, consider. Okay, I think I did a little bit of a wrong answer in the previous one. 10 raised to 9, 334 squared. If it will square this one. Okay. Much better way than that. That'll become 18. That'll become 1 squared plus 1 minus 1. Wait. Let's try to clarify this one. Okay, so we know again that that will be 3333. Okay, wait. Oh no. For this question here, we'll be having 10 raised to 9 minus 1 all over 3, then plus 1. Quantity squared, like that. Quantity squared. So if we do that one, what will happen is this, everyone. We will know that will become like 10 raised to 9 minus 1 quantity squared over 9. Then there's a quantity squared of this, like that. Okay, all over 9, quantity squared. And then what will happen plus, you'll have like 2 times 10 raised to 9 minus 1 over 3, the sum of that one, over 2. then plus 1, like that. So that's actually what we're having. We're trying to find the exact value of this. So as you can see, if we do that one, 10 raised to 9 squared is like equivalent to 3, 3, 4, 1, 1, 1, 1. Wait. 3, 3, 4, 1, 1, 1, 1. That's 10 raised to 9 minus 1. For those who wanted to go until 3 p.m. tayo, pero for those who wanted to say, you can say behind to finish this one out. 10 raised to 9 minus 1. And then you'll be having divided by 9. Divided by 9. Okay, tama ba? So it'll become like 99999 squared. Okay. Become 1. That's like 33333. Or that's like 11111 times 99999. Like that. It's better for that. Wait lang. Teka. Wait, everyone. Okay. Again, if you want to what we call this one, use your microphone. Please wait for me to acknowledge you. So for this one again, we'll be having 10 raised to 9 minus 1. Okay, so if you'll add by 1, that will become plus 3. So it's 10 raised to 9 plus 2 all over 3, like that one. Oh, so that's 10 raised to 9 will become like 1002 divided by 3, then quantity squared, like that one. Okay, then we square that one out. That will become like 10 raised to 18. Okay, plus 2 times 10 raised to 9. 2 squared or 4 times 10 raised to 9 plus 1, like that, plus 1 all over 3. Okay, so like that one. So that is actually what we have here. Now, if we want to try to simplify this one, we can actually try to see the because of that we can actually now I think better way is that we now know how to expand this one out. We have now 1 and then 18 na 0. Then there's a 4 and 9 0. So 18 0. So 119. I think that's a better one. We'll try to do directly na lang. That will be the shortcut of the squaring that one. But when you divide it by 3, we'll be doing it manually. So 1, 2, 3, 4, 5, 6, 7, 8, like that. And there's a 9 here. The 9 0, then we have 0, 2, 3, 4, 5, 6, 7, 8, then 1. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then there's like 10, 11, 12, 13, 14, 15, 16, 17, 18. That's 18 0. That will be the case. And then we just divide it by, okay, no, that's not 9, that's 4. Okay, 4, like that one. Then plus 1. Would be divisible by 3. Wait. No, plus 2. There should be plus 4 in the latter part. Sorry. Plus 4 here in the latter part. So that's the one that will be dividing it by 3 manually after that. Okay, because we can actually divide it by 3 na, they'll become like 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, then 5 here, 5, 5, 5, 5, 5, 5, 5, 5, and 6. And that will become the answer to that question. Plus 4. It's plus 4. Sorry. Oh, no. Sorry for that one. It should be divided by 9. Okay, so it will be 9. Actually, that's the correct answer still. That should be by 9, and that will become the correct answer still. So sorry for that one, everyone, again. Okay, let's try to put it correctly. That should be 10 plus, that will become like 10 plus, so because we'll be adding it by 1, okay, to be exact na lang. 10 raised to 9 plus 2 all over 3, quantity squared. So if you square that one, it'll become like 10 raised to 18 plus 2, that's 4a. That's 4 times 10 raised to 9 plus 4 divided by over 9. So expand that one out. That's like 18 is 0. Dapat. Pero 1, 2, 3, 4. That should be 18 zeros. Then 2, 4, 6, 8, 10. That'll become like 4 here. 1, 2, 3, 4, 5, 6, 7. Then there's 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then you divide it by 9. After that, you'll get 1, 1, 1, 1, 1, 1, 1, 1, 1. Then here, remainder 1. That'll become like 50. That is 5, 5, 5, 5, 5, 5, 5, then 6. And that's a correct answer for that one. Question clarification for this before we move forward to our next number. 3 or line na 9, then 5, 5, that's 5, 5 here, 5, and that one, the case. Question clarification for that one, everyone. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 numbers. And yeah, that should be the correct number of zeros, by the way. So that's like this is like 1. There should be like 1 and 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then there's 1 here. So that's 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, then 5, 5, 5, 5, 5, 5, 5 in the latter part. And that's the correct answer for that one, everyone. Question clarification for this before we move forward to the next number. Okay, let's try to move forward to the next number. Let's try to make it fast. By Pascal's triangle, what will be the coefficient of x for this one? So as you can see, the x is in the latter part, no, the last one. So the Pascal triangle, like the last two number, that will become 1, 1, then 10. Therefore, you can answer it to be 10. It's a little bit easy lang for that one because it's like the 10th line. So automatically, they'll become 10 because x is the second to the last. So the last coefficient is 1 and then 10 siya. So therefore, that's will become 10. 1, 1, 1, 1, 1, 2, 1. That will become like 1, 10 here in the latter part. And x is in the latter part. And the constant is 1. So therefore, the answer for that one is 10 for number 23. Okay, hoping that is clear for Pascal's triangle. Try to move forward with a faster one. Square ABCD. And then there's lies E and F, A, B, C, D. And E and F lies on BC. E and F and CD. CD. Okay. CD. So F here. Then angle AEB, A to E to B is twice D to A to F. Twice of that. Okay. 2 times. What is, and that will become twice of that. Then what is, if B is 11 and DF is 8, okay, AEB is twice. So this is like X. This is like 2X. Oh no. The other way around. The other way around. So that will become like X here. Then this will become like 2X here. Okay, X. This will become 2X. So 8 there and 11. Find the length of A to E. That's the question. Length of A to E. So this will become a little bit of an angle here. We know that that will become AEB. So here is AEB, then D to A to F is twice of that one, yung AEB. We'll try to find the length of A to E in this question. So BE is 11, DF is 8. Okay, I like that one. So that is what is asked in the problem. So as you can see, in terms of the right triangle, their angles here, X here, and 2X, if it's 11, that means that twice yung angle dito on the other side. In terms of the ratio, we don't know kasi exactly the same height, but we know that they have the same height here. Okay, so because they have the same height, H here, okay, by Pythagorean theorem, in terms of the ratio of their angle, okay, we know that H squared, because that's X, that's 8, 2X, can we have 16? Or try to have AB, wait lang. 11, 16, the answer is like 19, right? 19, okay. Oh, because of that, 8. And then your AE is actually we're trying to find. So we know that, is it the correct term? E is on the length of BC and F is on CD. Then we have A to E to B is equivalent to twice of D to A to F. That's 2X. Try to find the value if B is 11 and DF is actually 8. BE is 11 and DF is 8. So we're trying to find the value for AE. So that is what we asked in the problem. So we know that here we have some parts that we can use as the values there. So we know that the length here is like 11 minus 8 here, or H minus 8 here, and then AE. this will become h minus 11, like that one. So that's the graph for that one, or for our question. Now we're trying to find the value h minus 8. So we're trying to find now the value of the one. Because of the angle is given like that's 2, if we try to draw it here, half of that, that'll become like x and x. Like that will become angle bisector. So the ratio between them is like x and x. We can get this one x and x like this. So because of that, we have 11 here is to blank. In terms of the ratio is h. H is to 8 here is that we can have the ratio for that. H is to 8 will become equivalent to, because of that, we can create an equivalent triangle for that one. And because of the angle bisector theorem, the x and x theta, this will become x and x. We can see that your AE is to 11, like that one, is equal to um, the ratio of this one, the h, let's say h minus 11, 11 there, 8, can we have that one as the angle? Wait. For that one. Okay, wait. Oh, sorry for that one. Nawala yung ano. Okay, let's try to clarify and let's try to write that one properly. Okay, so here, let's try to use this one. Annotation button na lang. Okay, na-pause yung screen. I'm so sorry for that. So again, you have a square ABCD like that, right? ABCD. So you have a square ABCD. So having the square ABCD, you have AEB. The triangles like are angles like you have A to B to C to D, like that. Try to use that one. Then after that one, what will happen is that you'll be having AEB. There's a AEB, A triangle or A to E to B is twice of A, D to A to F. Let's say F is here, right? That one, twice of that. Okay, that's the angle there, twice of that. So E, this one is E, this is F, like that. And we know that B to E is 11. Oh, and E to F is 8. Now we're trying to find the value of your AE based on that one. So as you can see, we know this is X here. Let's try to say this is 2X for that one. Okay, and this is a right angle. They're actually in the right angle form. Okay, so after that one, we'll try to find out the value. If this right angle, this will become like 90 minus 2x, that one. If that's 90 minus 2x, that means this is also x, like that. This is x. So similar angles sila x lang dyan, right? That one. Now, that's 90 minus 2x is x. This will become 90. This is 90 minus x, like that one. If you try to have, this is 90 minus x, so they will become right angle here. Okay, wait lang. If this is a right angle, can we have, no, we cannot have that one. We cannot find the value for that. Okay, so it's a little bit of a challenging for that one. Okay, so for this one here, this will become 8. We know that is actually the length here of the side. Oh, sorry. And then we are going to find the value. This is like the side of the square, side of the square. So we're trying to find the value of your A to E, right? A to E. So that is actually what we're trying to get. So to solve for that one, since 2x ito, so become 2x also on the other side. Okay. Yeah. Okay, that'll become 2x. So we can actually connect this angle here because of the fact that we know that this will become 2x also based on that. Now, if that's the case, 2x, isosceles siya, that'll become isosceles triangle. Yeah. That'll become like x. Wait. X isosceles. Become 2x here. Now we can conclude that to become 2x also. There was the angle here. That will become the angle in the other side. Okay, wait. Let's completely half. That's the case. That'll become the angle. Okay. Okay, BE is equal to 11. And then DF is equal to 8 for this one. Now we're trying to find the length of AE. Teka. So for this one, what will happen? AE is equal to number 24 na ito. Okay, so for this one here, we're trying to get the value of your EE. So the one thing that we can do for that one is actually, we can cut this angle into X kasi mag-create tayo ng similar triangle with that one. If they will cut that one by angle bisector, we actually can create a similar triangle in such a way that because of that, this side here will be like in the ratio S is to 11 like that is equal to this side is to 8. Okay, we don't know. Let's say this is like A here. A is to 8. Like it'll become like 8 or S is to 11 because that's the opposite of uh beside the angle here, 11. And that'll become 8 is to A, like that one. And then because of that, we can actually equate that one also by angle bisector theorem. The angle here, if they're equal, that means that let's say this is A here, that like S minus A times S minus A is in the ratio of what we call this one, 11 is to AE. A is S minus A, which is equal to the ratio of S is to 11. Because the ratio for that side will create now A is to 11. S A is to S minus A, then it'll become AE. That we're trying to find yung AE natin. Now, because of that, yeah, EE is equal to the number of side. They're all equal to each other. Okay, wait, yes. Question clarification. The middle is X. By isosceles triangle or by isosceles, but this is 90 minus X kasi. If it 90 minus 2X. So therefore we can say that this is also X on the other side. So from that, okay, teka. From above, teka. Wait lang. Let me clarify this question. Oh, yes. Yeah. Teka. Wait. Okay, wait. For this question, tama ba? A, B, C, D. Did I graph it together properly? Tama yung pag-graph. Okay. Let me clarify first, ha? Parang mali yung in-draw ko and then the other version. Wait. So for this one again, what will happen is that you'll have A, B, C, D, right? A to B to C to D to E. One more time. Okay, A to B to C to D. And then you have E, B, C, that's E here. And then your C, D will become F here, like that. So then the ratio, the angle that is formed is twice. That's the only given. And we have BE is 11 and DF is 8, like that. We're trying to find the length of A to E in this question. So that is what we're trying to find. So this is like 2x here, like that, 2x. Okay, now, with that one being said, this is 2x, that's 11, that's 8. We know that this is the side of the triangle. Now we're trying to find now the value of each one and maybe try natin to find we know this is x right now here, right? And then again, because this is 90 minus 2x, we can say that this is also x to balance out the whole 90 degrees here. So that's what we have there in this given. Now, in this side, if your 8D is actually one of the sides of the triangle like that, okay, this is also S for that matter, we're trying to find your AE. So we know that your AE is actually equal to S squared plus 11 squared, like that, square root of that. Okay, that's your AE. That's what we're trying to find. Now we need to find that value in relation to, oh no. Okay, okay. Sine X, tangent X, tangent 2X. Okay, arctangent 2x. 2x to side x, S. Sine x, okay, tangent x, okay, 2x, sine 2x. Wait. Now, if that is the case right now, then x. Okay, yeah, we can actually, oh, that's it. Okay, no. We can get it now, right? Here, okay, we'll be using tangent pala dito. I forgot that one initially for the solution. So as you can see here, we can use the property of tangent. So if you have like tan 2x, like that, tangent 2x is equivalent to actually tan x over, that's equivalent to tan x or 2 tan x over 1 minus tangent squared x, 1 minus tan squared x. Okay, why did we have that one? Because the tan 2x here right now is actually opposite of our hypotenuse is s over 11. And then your tan x is 2 times opposite over hypotenuse, that's 8 over s. 8 over s, like that one. We can use that one so that we can get the value of your s. So 8 over s times 1 minus tangent squared. That's 2 or 1 minus 8 over s quantity squared, like that one. Quantity squared. And we can do some cross multiplication because of that. So by cross multiplication, what will happen is this. You'll have s minus 8 over s or 64 over s is equal to what we call this one. That's equivalent to 16, 2 times 16, 16 times 11. We can get the value of your s. 16 times 11, that will become equivalent to 16 times 11. We'll be using tangent. That's 176. So it'll become like s minus 4. We'll try to cross multiply. That'll become like 16. That's 176 over s. And then we can just transpose it. So s is equal to 176. That's 200. That's 10 carry 1, 240 over s. So therefore, s squared is equal to 240 actually. 240. Okay, because of that, we can now find AE. So your AE is just equivalent to square root of s squared plus 11 squared, which is eventually equal to 240 plus 121. That's equivalent to 200 or 361. And square root of 361 is 19. Okay, so we'll be using tangent pala. Initially, nawala ako. We'll be using tangent for that. And that's why the answer is actually 19 for this question. Question and clarification for that one before we move forward to our next problems. Okay. So the challenging one. The rest of the problems are quite easy na, so we'll try to finish it out. That's the answer for that question. Okay, that's why it's 19. Tangent 2x. Formula ni tangent 2x for that formula of tangent 2x. I'm so sorry. I know that there are others that are not from the Philippines. That's why sometimes I'm going back with that one. So with my usual language. Okay, but let's try to finish this one up. The rest are easy na for that matter. Let's try to move forward. Factor this one completely. So to factor this one completely, we need to just expound this question, right? Expound this question. So how do we expound this question? We'll be having a times a squared minus 1 times a plus 2. Or we can have a squared plus 2a, or later we'll be having that one. Okay. So what will happen is like you'll have a plus 2. A plus 2, like that one. A plus 2. So a plus 2 plus 1. Then after that one, you'll be having a times a squared or a cube. We'll try to multiply now a cube. Then we'll have a squared times 2 plus 2a squared minus a minus 2. Okay, minus a minus 2. Sorry for that. Let's try to slow down a little bit. Okay, so we'll have, again, we'll be having minus a minus 2 plus 1, like that. So we'll be having like a raised to 4 plus 2a cube, 2a cube. Okay, you'll be having 2a cube minus a squared minus 2a plus 1. So then we factor that one out. Now, how will we factor this one out? As you can see, that will become like a squared minus 2a plus 1 in the middle. We'll try to find the factor for that. It's a little bit of a challenging one, but you have like a raised to 4 minus 2a squared plus 1. So how do we factor this one out? As you can see, meron tayong 2a for that. So as you can, if we'll try to a squared, tama ba? Minus a minus 1. So that'll become the correct answer. So to try to factor this one, there's a pattern of a plus 2a plus 1. So actually we can have, or we can add, okay, or we can group together actually the one in the middle. You'll have a raised to 4 minus a squared plus 1. Then we group together your 2 plus 2 times a cube, or 2a cube minus 2a, like that. We can group that one together. So if you group that one together, this one is factorable to be what? This is plus 1 will become like a squared plus 1 minus, or a squared plus 1 minus a squared. If you'll be adding that 1 minus a squared, 8 is to 4 plus 1. Teka. By completing the square, minus a squared, that will become minus 2a. If you do completing the square for this, teka. Tama ba? Minus, negative. So try to factor that one out. Okay, teka. Sige. Okay, 8 is to 4 minus 2a squared. Yeah. Okay, to make it short, actually, we need to try to factor this one out. This will become like a pattern na parang in the middle yung 2a. So if you'll try to group together, this one will become the factor. A raised to 4 plus a cubed minus a squared, like that. Okay, minus a squared. Then there will be like another a cubed minus a squared, minus a squared, or plus a squared minus a, like that one. Okay, we'll try to regroup them together like this way. As you can see, we can have that one kasi 2 to 1. Then we can have like minus a squared minus or plus a, or minus a, yeah, minus a plus 1 to balance it out. Okay, if you try to do that one actually, and then factor out the number, okay, sorry, we regroup them together. Okay, wait, sana yan? We're regrouping them together. And that's the way para kompletuhin natin yung factoring, minus a plus 1. As you can see, we break out the a cube, we break out the negative a squared. That will become the case. And as you can see, there's a pattern for that. We can factor out actually a squared plus a plus 1 for each of this factor. If you do factor that one out, what will be left on the first set, that will become a squared. On the second set, that's plus 1 or plus a, then minus 1 on the latter part. So therefore, or this was minus 1 actually to. Therefore, the factor of this is actually a squared plus a minus 1. Pero a little bit of a completing the square or completing the factor and breaking them out into that form. And therefore, that's the correct answer for that question. Question clarification for that one, everyone. Okay, again, you can stay behind and we'll try to finish everything until what we can finish for this one. So as you can see, okay, let's try to move forward to the next one. How about if you do have the situation? If you have the situation. Okay, next question tayo. For that one, let's try to go in question number 26. So if x is the minimum, what's the minimum value? Just right answer, what's the minimum value of x squared plus 1 over x squared? So for this one here, the minimum value, if both of them are equal to each other. So actually, they will become equal if x is equal to 1 lang. And therefore, the minimum value of x squared plus 1 over x squared is 1 plus 1 or 2. Okay, actually, that they will happen if that x squared is equal to 1 over x squared lang. And that's the case. So the minimum value for that one is equivalent to 2 for this question. Okay, that's actually the case for that one, number 26. Number 27, okay, summation of perfect cube. So if you add perfect cube, 1 cube plus 2 cube plus 3 cube, let me have it fast for this one, is plus that until n cube, that's actually n times n plus 1 over 2 raised all over 2 quantity squared. Okay, like that one. So basically, we can square it that one. That's basically n times n plus 1 over 2 na lang because our that's a summation of cube. And then you square it at 1. That means that's n times n plus 1 over 2. For this case, that's 100 times 101 divided by 2 na lang. 100 times 101 divided by 2. And therefore, because of that, 100 times 101 divided by 2, that's equivalent to 5,050 na lang for that question. Okay. I'll try to have that one. Next one, question number 28. This is like the nesting and the nesting and the nesting. Okay, that's similar to the question. Okay, your 3 minus 2 square root of 2 is actually equivalent to square root of 3 minus square root of 3. Okay, square root of 2 minus square root of 1. Square root of 1 squared, like that one. So the nesting and the nesting and the nesting for that one. So as you can see, medyo magti-nest tayo how many times here? For the case of square root of 3, 3 plus square root of 3, or square root of 3 minus 2 square root of 2. That what two numbers adds up to 3 in product is 2. That's 3 and 1. So therefore, what will be left is 4 square root of square root of 3 minus square root of 2 minus 1 squared. So makakancel out. That is 4 square root of 2 minus 1. Then magpa-plus kay 10. So that's 10 plus that 1. Square root of that again. But we'll be denesting this part again. The square root of 9 plus, you can put the 2 inside. That's like 2. So the other 2 is 4. That's 8. So what two numbers sum of 9 product is 8. That's square root of 8. Square root of 8 plus 1 squared. Then again, makakancel out again yan. So it'll become like 23 minus 6 square root of 8. Then plus or minus 1. So it's like 22 minus, you bring down again 2, you put the 3 inside. 3 squared is 9, that's 72, like that. 23 will become plus 1, right? Minus, okay, plus 1, yeah, plus. So it'll become like 22. What that is? 8, 2, 6 square root of 8. Yeah, it will become 6 square root of 8 talaga. So square root of 8, 1. Yeah, 9 kasi. So what two numbers? 23 minus 1. Pag minus 1 kasi yan. So it'll become 22 minus 2 square root of 72. I-did-nest na naman natin ito. So what two numbers? Product niya 72. Their sum is 22. That's 9, 9, and 72. 9 and 9 and what? 9 times your 72 is 9 times 8. No, that's 22 lang. Ano ba? 72, sum niya 22. What? 18. 72 divided by 18. That's actually 4. Yeah, 18 and 4. Right? 18 and 4. Yes, that's correct. Okay, so that'll become like, again, magiging square root of 9 ito. Then that'll become minus 2 square root of 18 minus square root of 4, which is 2. So distribute that 1. That will become 8. Okay, minus 8 kasi, no, plus 8 ito. Will become like square root of 17. No. Ano ba? 17 ba? Minus 2 times square root of 18. Tama ba? Kasi the 22 minus 2 square root of 72, that's, sorry. Pero nag-ano ako, bakit nag-ano ako? Bakit, or we'll try to have the continue with that one. So again, this one here, maka-cancel out na naman yung radical natin. This will become like square root of 18 minus square root of 4. Like that one, which is 2. So ilalagay natin, or we'll try to put it with negative 2 or 9. Makakancel, this is quantity squared. So that's 9 minus square root of 18. 2 square root of 18, then minus, or it will become plus. Okay, plus 2. So therefore, that will become 11 minus square root of 18. So what two numbers add up to 11 and the product is 18? That's 9. So square root of 9 plus square root of 2, the final answer will become 3 plus square root of 2. It's a multiple denesting until you get 3 plus square root of 2. And that will become the answer for that one. 3 plus square root of 2 for question number, for question number 28. Is that correct? Minus 2, that's 2, 11. What two numbers? The sum is 9. The product is, no, the sum is 9. And the product is 18. Correct, right? 18 and 4 for 72. Plus 18 minus 4. That's 2. 2 times 18. Radical 4 plus the 11. What two numbers? Product is 18. The sum is 11. That should be 3 plus square root of 2, I think. There's a typographical error in the answer key for that one. That should be 3 plus square root of 2 for that. And then last but not the least, no, not yet. Number this one, solve for this one. Okay, for this question here, we can just basically multiply them, x squared, y squared, z squared, similarly to the previous question. This is a product of 20 times 30 times 24. Then we square it at 1, x, y, z is equal to the square root of 20 times 30 times 24. So 20 times 30 times 24, okay, to make it fast, that will become equivalent to 1,444. Square root of that will become equivalent to 120. So this is 120 right now. So for your x, we divide it by 24. That's actually 5. To solve for your y, we divide it by, no, to solve for your x, we divide it by 30, I mean. So that's 4. X is equal to 4. Okay, we divide xyz, okay, by, first, x will become 120 divided by 30 here, so that x will become 4. Then 120 to solve for your y, 120 divided by 24. To solve, maka-cancel out yung y for this one. That will become 5. And then 120 divided by xy, which is 20, that will become 6. So therefore, that will become 6, and therefore, that is the answer for question number 29. And last but not the least, okay, I'll be finding this one. The length of the hypotenuse is square root of 17. Find the remaining lengths are integers. Find the number of right angled triangles to satisfy the above mentioned triangles. So we know the square root of 17, this one. We wanted to have a right triangle. We know that we'll have a sum of one perfect square, 1 squared, 16 squared. Find the number of right angles, triangles that we have in 16 squared. We don't have, no. That's 1 plus, I mean 1 plus 4, back in 16 squared. So we'll have only 1 squared plus 4 squared for that. And 17, and there's only one way for that. 1 squared plus 4 squared, which is 16. And that's only one right triangle. Meron pa bang iba? Yeah, there's only one. That's the only case for that one. That's a 1, 4, 17. 1, 4 square root of 17 right triangle. So the answer for the last one finally is 1. And that's the answer for our question, everyone. Okay, hoping that you learned something from me. Medyo there's some questions that are a little bit make it fast to discuss because of some constraint for that one, and everything was discussed naman properly. And I mean, hoping that you can review lang the videos that will be sent to you. I think that will be it for the meantime for today. Have a good day, everyone. Bye-bye. Hoping that you learned something from this discussion. Bye-bye. Bye-bye. Bye, everyone. Goodbye.